So on your calendar, Monday, you have a quiz. That quiz will include everything that you will have in your ISN, or it's okay if it's not glued in yet, but everything we've done Tuesday through Friday could possibly show up on that quiz. So that's what that is. Then I want you to look at this piece of paper. So a flow chart for factoring. The yellow bar up at the top says, first, always factor out the greatest common factor, or GCF, if one exists. So that key part of that is if one exists, because it may not exist, right? There's a little disclaimer down at the bottom that basically says, if the GCF doesn't have a variable in it, you don't have to factor it out to solve, but it does make your life a little bit easier. But if you're just told to solve and you don't factor out a GCF that's a number, you'll still get the same answer. But if you're told to factor completely, then you will not get the same answer because it won't be factored completely, if that makes any sense. But it is a good idea to do it because it will make the numbers better for you to use. But then you look at, is the equation a binomial or trinomial? If the answer is no, so it has 4 or more terms, grouping is the way you want to do it. That's why understanding grouping is important. If the answer is yes, and it's a special case, then here are your special cases for binomials, your special cases for trinomials. And then if not, then you have some options to choose from here. Factor by grouping, completing the square, or using the quadratic formula. You don't necessarily have to factor by grouping if it's a trinomial, like if you prefer like the guess and check method because you can manipulate those numbers and factors in your head, that's fine. That works better for some people. For most of us, that's, it doesn't come quite as quickly maybe or make as much sense, but that's fine. I'm not saying you have to do grouping if you can do it right the other way. But if you're still drawing a sad little box and stuff, you ain't got time for that anymore. You got to get over that. One thing that may not have been brought to your attention before is when you have the sum and difference of cubes, there's a little acronym that says that's SOAP. You'll ever use the SOAP acronym for that? So if it's the difference of cubes, the SOAP stands for same, opposite, always positive. So the pattern you're usually okay with, it's the signs you get mixed up sometimes. So since this is the difference of cubes, the signs are the same, opposite, always positive. So when it's the sum of the cubes, the sign is same, opposite, always positive. That's your SOAP can kind of help you make sure you get that right. So this is there for your reference. If any of this looks completely foreign or you struggle with it, I would spend a lot of time on Khan Academy this weekend and getting these skills freshened up and knocking all the cobwebs off because it's something that you've got to be able to do. All right, so let's start with some factoring review. We're not going to do all these. Let's see. We're going to start with number 8. Okay. And so, although I'm going to talk you through some grouping, again, if grouping is not the way you would want to do it, that's fine. I'm not saying you have to do it my way, but you have to do it in a way that works, obviously. So, can I factor out the GCF here? No, there isn't one, right? So, then what would be the next thing I need to do? To be able to factor it, what do I need to find? Do I need to multiply something? Yeah. 7 times 24. Okay, so multiply 7 times 24. So what's 7 times 20? 140. 7 times 4 is 28. So you put those together and you get 168. Okay, so 168 is a big number. Probably not a number where you just know the factors in your head, again, unless you're just someone that can manipulate things like that. And so when that happens, there's probably a whole lot of guessing and checking going on, right? You're going to divide and see what happens, and that's fine, but that takes time sometimes, and sometimes if you don't divide correctly, then the one that was actually working you miss because you think it didn't work. But I know at least 2 numbers to multiply to give me 168. That's 7 and 24, so that's one little set of numbers, right? But if I do my prime factorization of that, I'm going to divide 24 by 2, and that gives me 12. 2 again, it gives me 6. So here's the prime factorization of 168, right? Because 2 times 2 is 4, times 2 is 8, times 3 is 24. So this is the same thing as 7 times 24. If you can look at it that way and then think about how you can regroup your numbers. If I do just 2 times 2 times 2, that's 8, and 7 times 3 is 21. There's another set of factors right there. I can do 2 times 7, which is 14, and 2 times 2 times 3, which is 12, right? Instead of actually trying to divide by 12 and figure it out. You with me on that? If you can understand how these numbers are built, you can simplify your life without trying to do random stuff all over the place all the time. So then I can do 2 times 3, that's 6, and 2 times 2 is 4, times 7 is 28, right? I can also do just 2, right? And then I can, what's half of, like you can either multiply them together, or half of 168 would be 84. Maybe in that case, it's easier to divide than multiply the other numbers. You with me? So you just don't have just one way, have different ways to come up with your different possibilities. So that's not even all of them, because I could use 1 and 168 and some others. But when you do that, I need them to multiply to give me this number. Do they need to add or subtract to give me 34? Add. So is my option that I need here already? What is it? 6 and 28. I think I heard 16 somewhere, but 6 and 28. Right? You don't even have to think that hard. So now I'm going to write this out, and I'm going to get 7b squared. Does it matter which one comes first? No. So plus, we'll do 6b plus 28b plus 24. Then I'm going to group these together. And what can I factor out of the first set? B. So you get b times 7b plus 6 plus, what do I factor out of this? 4. Good. And that leaves me with 7b plus 6. And I would expect that I would get the same thing, right, in both of them? So you do understand that the next step that you do is actually factoring out the GCF. Because now the greatest common factor of these two factors is this 7b plus 6. So when I factor that out, 7b plus 6 gets factored out. I'm left with b plus 4, and I have it factored. Do I set them equal to 0 now? Good. No, because it doesn't say solve. What's another reason? There's no equal sign. Those are two dead giveaways, right? First of all, the directions say factor completely. So even if there was an equal sign, you still would stop because it says factor completely. But if you were unsure, the fact that there's no equal sign also kind of gives it away. You can't solve it if it's not an equation. So we're done. Don't do too much. And also make sure you've done enough if necessary. We good? Yeah? All right. Let's look at 12. So can I factor out a GCF here? Yes. What is it? 5. So 5. So I have 5, and then I'm left with 3b squared minus 11b plus, not 10, my goodness, plus 6. Right? So it's nice when we factor out a GCF if a is 1, but it's not. So we have to still do kind of what we did up there. So now I'm going to do 3 times 6, which is 18. So that's not nearly as big as 168, so maybe I don't have to think about it the same way. Coming up with those factors is not that big of a deal. But I do have to pay attention to the fact that since this is positive, that means the two signs that I'm going to use have to be the same. They're either both positive or both negative. Since this is negative, are they going to be both positive or both negative? Negative. And they're going to have to add together to give me that negative 11. So what are my two factors then? 9 and 2. Good. So 3b squared minus 9b minus 2b plus 6. Now, the reason I'm doing this one, even though we just did one like this, is because then you have to be careful about your parentheses and what you're saying is being multiplied. Because you have to make sure that at every step on anything that you're doing, that your process makes sense. And that it's not just, oh, well, I know what that's supposed to be. Well, it doesn't matter if somebody's trying to follow your process. So I'm going to make this into a bracket. So inside my brackets, I can do my grouping. So I don't even confuse myself with my parentheses, right? So out of here, I can factor out a 3b. So that's going to leave me with b minus 3. What do I factor out of here? Negative 2. So that leaves me with b minus 3. Okay. And then after that, I can drop my brackets. It just kind of separates it more so I don't leave off a parenthesis or whatever. And that's going to give me 5 times b minus 3. Times 3b minus 2. What was the question? Because I might be the only one thinking it. What?
Saying what does the sign do after you take the brackets off?
Okay. And what does it do? If I was actually solving it, it doesn't do anything. Like, it doesn't change my answer if I was solving it. That's not going to be affected. but you still can't drop it off because it's still part of, I still at any point have to be able to multiply it all back together or solve it all back out and get that back. So it's still important. Good question. Anything else? He just hangs out there out front and waits for everything else to be done. Okay. All right, now let's jump back up to number 4. Now I left number 4 last on purpose, and even though it's the easiest one, because what I have found, now as students, come up through in algebra and then get to me, they learn factoring in different ways, different years, right? That they decide that, oh, this is the way everybody should learn it now, and things change. So as grouping has become kind of the norm, even if it's not the only way you learned it, you should have learned grouping. I have noticed some misconceptions for people, which I'm hoping you're kind of past since you've been through Algebra 2, but just to make sure I have said it so nobody's confused. When I do this, because I think some of you were taught this way, that you were taught to kind of always do grouping. Grouping is not necessary here. It's possible, but it's not necessary because I don't have my A is 1. So when I do this, I can multiply 1 times negative 30. I mean, it's negative 30, right? But I do know if I don't have a coefficient here, that it's just going to end up like this. This is B, right? This is negative, which means my signs are different. And then my 2 factors of 30 that would subtract to give me 7 would be what? 10 and negative 3. So 10, and then this would be the negative 3. And I'm done. Where what I have seen, and this is where people get confused, like if it's one of these, it's not that big of a deal and you're fine. But then when it's like this and you try and force it down the grouping road, which again, you can, I don't know why you'd want to, but you can. I mean, you can do this and then do your grouping, but do you see why it's not necessary and you're wasting your time? Like, you don't need to because you already know what parts you need. So if you are doing that, like, learn to stop doing that and simplifying things for yourself, okay? And we're done. Any questions on those? All right, so that was your quick factoring review for now. Let's put that aside and grab the other green paper you have. All right, so X and Y intercepts, it's going on page 28 when we're done. So intercepts are points where a graph intersects the X or Y axis. Kind of a no-brainer, right? An x-intercept occurs where y equals what? 0. And a y-intercept occurs where x equals 0. There you go. Now we've talked about functions and relations. Right now we're just talking about functions. So a function can have 0 plus x-intercepts. Maybe I don't have any. Maybe I have an infinite amount. Just depends. But at most, 1 y-intercept. You can't have more than 1 y-intercept if you're a function, or you're going to fail the vertical line test at on the y-axis and maybe other places as well. So at most 1 y-intercept, we could have more than 1 x-intercept, right? So keeping our focus on being able to write things and notate things correctly, when you write your answers for x and y intercepts, what do they have to be? Ordered pairs. They have to be ordered pairs. They are not single numbers. You don't list them out. They are ordered pairs if you ask for an intercept. So when we look at number 1, how many x-intercepts are there? 1. There's just 1. It's right here. And what would it be? 4, 0. Okay? Super easy, right? Y-intercept, 0, 2. Okay? So this should be very simple for you. Make sure that you put the point in the correct form, meaning don't get the 0 in the wrong place, because I know you know where it goes. Just make sure you don't have a brain fart there. All right, so number 2, how many x-intercepts are there? There's 4. There's 1 right here. 1, 2, 3, and 4. So my first one is negative 1, 0. The next one is 1, 0. And then 2, 0. And 3, 0. Is there a y-intercept? Yes. And it is at what? 6. Everybody good with that? All right. How many x-intercepts do I have on number 3? 2. Okay, so they are at negative, is that 4? Okay, negative 4, 0, and 2, 0. Y-intercept, one of them. So it's 0, negative 2. So are these pretty easy? Yes. So we're going to do the next 3 anyway, even though it's not necessary, because when it's easy, we don't complain. We're just glad that it's easy. We'll move on. All right, x-intercepts. None. So my answer is none. Y-intercept. There's one of them, and it is at 0, 5. How many x-intercepts in number 5? 2. So we're here at 3, 0, and 7, 0. My y-intercept, here's one of them, 0, negative 6. All right. X-intercepts on 6, none. Y-intercepts, none. Okay. We're all good on that. Visually from a graph, we can handle that, right? All right, so let's talk about them algebraically. So we're going to look at zeros. Have we already kind of talked about zeros? Yes. What do zeros relate to in what we just talked about up here? The x-intercepts, okay? The difference comes in to how you notate them, right? Because you have x-intercepts, zeros, solutions, roots. They all represent the same thing on the graph. But with the x-intercepts, you write them as an ordered pair. You don't when they're zeros, because the zeros are the x values where the function intersects the x-axis. Okay. So it's just the x value. It's not the point or the ordered pair. It's not what the 0 is. So when I want to find the zeros and the y-intercepts algebraically, to find the zeros, I set f of x equal to what? 0. And what do I solve for? X. And to find the y-intercept, I just find f of what? 0. Because that means it's when I set x equal to 0. Okay, we good? All right, so it says find the zeros and y-intercept of each function algebraically. So we'll start with the zeros. And that means I'm going to set f of x equal to 0. So I get 0 equals negative absolute value of x minus 5 plus 3. So I've set it equal to 0. Now I've got to solve. Since the absolute value is negative, I'm going to move that whole term over to the left and make it positive. So absolute value of x minus 5 equals 3. How many answers am I going to end up with? 2. Because to solve this, I set x minus 5 equal to 3. And I also do what? Okay, so yeah, negative x minus 5 in parentheses equal, but I could just also do this, right? But you're right to officially get to that. I see what you're saying. And there's nothing wrong with that. It equals negative 3. Basically, I just put the negative on the other side. All right, so then that means that I get x equals 8 and x equals 2. So then when I come to actually write my answer for my zeros, I'm not writing ordered pairs. I'm not writing x equals. It is a set of values that I have, and it's 2, 8. Okay. So just so you are aware, we talk a lot about what the correct notation is, what it should be, how you should do. Like Mrs. Archer and I are always talking to Mr. Ackerman about making sure that you're getting what you need in pre-cal and that we're the notation and everything is right and consistent. And then I go and talk to Ms. McWhorter about that stuff all the time. And yesterday after school, she and I talked a long time about inequalities and the notation and this. And sometimes you see it this way, sometimes you see it that way. And even in some of the trainings we go to, coming down from AP, it'll say you have to do it this way. And then the next year they say, no, you have to do it this way. And then they finally go, we'll take it either way. So there's certain things that are like that. We're like, well, it really doesn't matter either way, and we can't reason either way. But one of those things is, like, we know for intercepts for sure, got to be ordered pairs. What I know from and I don't know what the other Algebra 2 teachers did, so that's why I'm referring to Ms. McWhorter, because I haven't talked to the other ones. But if it was an x-intercept, she had you write it as an ordered pair. If it was a solution set, you wrote it with the squiggly brackets. If it was zeros or roots, you listed the numbers, but there were no squiggly brackets. Does that sound familiar? Basically, all of them are sets of numbers, and so they're all going to have the squiggly brackets on it. If it matters, the squiggly brackets need to be there. If it's one of those things where it's like, we'll take it either way, it doesn't matter if they're there or not. So I think the safer thing to do is let's go ahead and put them. Does that make sense to you? So anytime you're not putting it as an ordered pair, it's a set of numbers, so that's why those squiggly brackets are there. Okay? That makes sense to you? All right, so then y-intercept, we're going to find f of 0. So that's equal to negative absolute value of 0 minus 5 plus 3. So the absolute value of negative 5 is 5, but we're going to make it negative, so that's negative 5 plus 3. So f of 0 is negative 2. So my y-intercept is 0, negative 2. Everybody good with that? This should be, again, review for sure. All right, so we're going to find the zeros here. So 0 is equal to 2x squared minus 7x minus 4. What am I going to need to do to solve for x? Factor. And we can't factor out a GCF, so I'm just going to go with the grouping here. So I'm going to get 2x squared. Now 2 times 4 is a negative 8. And the signs have to be different, so they're going to have to subtract to give me 7. So that's going to give me negative 7, no, not it, I'm sorry, negative 8x plus x minus 4. So then when I group these, I'm going to get 2x times x minus 4. Then what do I factor out of this? No, I do. What do I factor out? A 1. And you normally don't factor out a 1. 1's normally something we ignore, but in this case, it needs to be there or we can't go any farther than that. So then that gives me x minus 4 times 2x plus 1. So I set x minus 4 equal to 0 and 2x plus 1 equal to 0. So I get x equals 4 and x equals what? Negative 1/2. Negative 1/2. All right, and then I write that in my little squiggly brackets here, negative 1/2, 4. Then I have to find my y-intercepts. So f of 0 equals 2 times 0 squared minus 7 times 0 minus 4. So that's pretty easy, right? What's that going to give me?
Negative 4.
Negative 4. F of 0 equals negative 4, which is 0, negative 4. Okay? Questions? All right. Number 9. Find the zeros. So 0 equals x to the 4th minus 5x squared plus 4. Can I factor that? Yes. Does it make it crazy hard because it's x to the 4th? No. I just treat this like a quadratic and it'll factor just fine. So I know when I factor it, then it's going to end up looking like this. X squared and x squared instead of just x and x. So two numbers that are going to multiply to give me 4, but combine to give me a negative 5 are going to be what? Negative 1 and negative 4. Can I factor that? Yes, I can. So that's equal to x plus 1. What? Very good. Difference of two squares. It's on that little flow chart. You got to know it. You got to be able to get it through it quickly. So then I set x plus 1 equal to 0, x minus 1 equal to 0, x plus 2 equal to 0, x minus 2 equal to 0. So when I solve these two, I'm going to get a negative 1 and a positive 1, so I can just say plus or minus 1. And same thing here, plus or minus 2. You can write all four of that if you want to, but learning how to combine things would be good so that you're not writing things out forever all the time. So plus or minus 1, plus or minus 2. Then for my y-intercept, f of 0 equals 0 to the 4th minus 5 times 0 squared plus 4. So that means that f of 0 equals 4. So my intercept is 0, 4. We good? Yes? All right, y'all work on number 10. So let me get kind of caught up with you here. Okay, so we have a GCF to factor out, right? Once you factor out that GCF, then it's not that big of a deal, and we get x, and then it's going to end up looking like this, right? And what are my two numbers going to be here? Negative 7 and 1. Oh, whoops, plus 1. There you go. So then I'm going to set, how many answers am I going to have? 3. Some of y'all just had 2. Okay, I've got x equals 0, x minus 7 equals 0, and x plus 1 equals 0. So there's one of them, and then I get x equals 7, and x equals a negative 1. So negative 1, 0, 7. If you have something that is factorable, if it's a cubic, you should have 3 solutions. Now, not every cubic function is going to have 3 solutions, right? Or, well, actually, I take that back. Every cubic function has 3 solutions. Every cubic function doesn't have 3 real solutions, right? And that's what we're getting here. When you start talking about imaginary, that's different. But if you can factor it and you're actually getting these, you should have as many as that matches that exponent there. So you got 3 of them. Don't leave off that 0. He's important. All right, so then we find our y-intercept. So I'm looking for f of 0. So that's going to be 0 cubed minus 6 times 0 squared minus 7 times 0. So what is f of 0? 0. Some of these, without substituting them in, should be pretty obvious, right? And that's good and fine as long as you understand why. If all these are going to 0 out, obviously it's 0. Even here, if I plug in 0 here and here, those two 0 out, so that's why I'm left with just 4. Okay. Some other ones we may need to work out a little bit more, but okay. I want you to do 11. Go ahead and work on 11 on your own. We can't ignore the fact that we have a GCF here. So to find my zeros, I'm going to have 0 equals 3x cubed plus 13x squared minus 10x. You don't get to just change it. There's no room for creativity here. So this is going to give me x times 3x squared plus 13x minus 10. Okay? So then I'm going to factor by grouping. So 3 times 10, negative 10 is a negative 30, right? So I'm going to have x. Here's where I'm going to use my bracket here. And I'll go ahead and put my 3. X. Oh, I guess I don't need my 3. I didn't need my bracket yet. But I need 2 numbers that are going to multiply to give me 30. Since this is negative, that means the signs are opposite. So are they going to have to add or subtract to give me that 13? subtract. So 3 times 10 is not my numbers. 3 times 10 gives you 30, but it is not going to work here because they have to have different signs, which means they're going to subtract to give me this. So what are my two numbers I'm using? 2 and 15. And which one's negative? The 2. Okay, so I got 3x squared. I'm going to have a positive 15x, a negative 2x, and then minus 10, right? So this right here should always get me back to this and also multiply to give me this. So now I'm going to group these two together and just factor the GCF out of these things. So I've got my x. The GCF here is 3x times x plus 5. Out of this, I can factor out a negative 2, which is going to give me x plus 5 there. Okay? So now what's in my brackets, the GCF in there, is that x plus 5. So that's where I get the x times x plus 5 times, and then I'm left with that 3x minus 2. And in my opinion, that is way easier than sitting there and trying to guess and check and process through all of that, unless you just have that kind of, those wheels turning in your brain, which some people do. Yeah, most of us don't, but some people can look at that stuff and you just, you process it quickly and that it just works for you. That's great. So now we have 3 things: x equals 0, x plus 5 equals 0, and 3x minus 2 equals 0. So here's one of them, x equals 0. Then I'm also going to have x equals negative 5, and x equals what? 2/3. So when I put them in here, I have negative 5, 0, and 2/3. If any of this is confusing, it feels foreign, it is something you just need a little bit more practice on, Khan Academy, I probably already said that a few times, but it is a beautiful place to go. It is good, decent stuff that will have little videos there for you. You can easily search stuff. I did learn today, had no idea, but when you go to the portal, there's a tile that you can click on called Clever. Has anybody mentioned that to y'all? I was like, how come nobody's told me this? So anyway, there's a tile that says Clever. I don't even know what it looks like because I just literally saw it 4th period. When you click on Clever and you're logged into the portal, then you're automatically logged into some other things, one of them being Khan Academy, which will tie you to my class. And eventually I'm going to have you do that. So if you want to play around, because I'm curious to know once you log in, I think it'll just, my classes are there and I have pending students, but there's no names. So I think once you log in, you like automatically become my student in there. But anyway, but you can go into Khan Academy that way. I don't know if anybody's ever told y'all that, but you can do that, try that, and then just, you can search in Khan Academy instead of just searching YouTube. I know there's a lot of Khan Academy videos on YouTube, but it's probably better to go in through there and get some practice, and you can just see some extra examples of these things that can help you, get it figured out a little bit better. All right. Then I need the y-intercepts, or y-intercept, sorry, should have been plural. What's it going to be? 0. Yeah, so I'm going to go ahead and write it out. F of 0 equals 3 times 0 cubed plus 13 times 0 squared minus 10 times 0. Now, do you have to write out all that work every time? No, but I want to make sure that if you're not really understanding where it's coming from, that you've got that for now anyway. All right. Let's do this last one together. Zeros. 0 equals the square root of x plus 1 minus 2. Do I have to do any weird stuff here? No. Should that be plus or minus? No, not unless you introduce the square root in your solving. If it was already there and they wanted you to do plus or minus, it would say plus or minus, right? So don't get creative and start adding things. I'm just going to move the 2 over. So 2 equals the square root of x plus 1. Square it. So I'm going to get 4 equals x plus 1. And you get x equals 3. Okay. So I just have one solution here. So it's still a solution set. The set just has one thing in it. And then for my y-intercept, let me look like a y. For my y-intercept, f of 0 is equal to the square root of 0 plus 1 minus 2. Square root of 1 minus 2 gives me negative 1. So that's 0, negative 1. Okay, we good on that? Any questions? All right, so the assignment that actually goes with this, you're going to get tomorrow because we're going to do another little set of notes with it. So the assignment for today that's due on Monday is finishing that factoring worksheet, which should take you 5 minutes, okay? If it takes you longer than that, that's okay, but get it figured out to where it won't take you that long, okay? And one of the things, guys, believe it or not, that will help you the most with factoring is knowing your multiplication facts. That is what slows you up the most. If you haven't already done it, go home, make yourself flashcards, get an app, do something, know your multiplication facts quickly, all right? And then get the factoring figured out, or that's just going to stump you on other things we do.